The question is, consider the following transactions with data items P and Q initialized to 0. T1, read of P, read of Q. If P is equal to 0, then Q is equal to Q plus 1, write of Q. T2 is read of Q, read of P. If Q is equal to 0, then P is equal to P plus 1, write of P. Any non-serial interleaving of T1 and T2 leads to option A, a serializable schedule, option B, a schedule that is not conflict serializable, option C, a conflict serializable schedule, option D, a schedule in which precedence graph cannot be drawn. So, a non-serial interleaving of T1 and T2 leads to, that is the question. Basically a serial interleaving or basically running T1 after T2 or T2 after T1. Non-serial is some instruction of T2 should happen before some instruction of T1. So that is non-serial. So let's take, without loss of generality, let's just assume that T1 starts before T2. So the first instruction of T1 is read of P and the last instruction of T2 is write of P. So in the precedence graph, there will be an edge from T1 to T2. Similarly, the first instruction of T2 is read of Q and the last instruction of T1 is write of Q. So there is definitely an edge from T2 to T1 also, which implies that there is a cycle in the precedence graph, which implies T1 and T2 are not conflict serializable. Similarly, if T2 starts, we will realize that T2 and T1 are also not conflict serializable. Therefore, option B, a schedule that is not conflict serializable, is the right answer.